Thank you, Rajul, for this nice introduction, and good afternoon, everybody. Here I'm trying to provide a short introduction to the discussion. Most of the seminar today is going to be about specific applications, and here I wanted to bring, why we organize the seminar and why we think it's important to discuss applications. As a background, I would say that IFPRI has organized a policy seminar in 2008, June 2008. I was part of it, and it was more generally about nanotechnology. There were two other prominent speakers, Mihai Hrolko from the National Science Foundation and Hongde Chen from the USDA. And we had a very interesting discussion about where the science was, where it was going, and what were the promises, etc. But we weren't able to really go into the reality. And so I thought, since then we have, as IFPRI, worked on a review paper and a brief that Rajul mentioned, trying to look at the opportunities, especially for developing countries in agriculture, food, and water safety, and what are the challenges to those opportunities. And we thought this second seminar that would bring more of the reality behind the application and what could happen for the poor in developing countries would be an interesting complement. So what are nanotechnology applications? Probably most of you in the room know much more than I do about nanotechnology, but one of the definitions that can be used is research and development that involves measuring and manipulating matter at the atomic, molecular, and supramolecular level, around 1 to 100 nanometers. So this is 10 minus 9 matter. It's really small materials. And the interesting things about those materials is that they exhibit specific properties that are often different from their bulk counterparts. So because of those properties, you can manipulate and have some interesting, technology that can be even revolutionary in some cases. So why discuss in application? I already sort of introduced this. If you read the media, you'll find a lot of things about nanotechnology, how great it is, how big it is, how it's going to revolutionize the world. It's going to be a technology wave, and everything will go away because of these new types of applications. But there's been significant investment as well and promises, but what is actually happening in the scientific labs? What is actually happening in those labs and those scientific institutions that work on those nanotechnology, especially in agriculture and food? That was the first motivation. The second motivation I had is that there's an international debate going on the governance of nanotechnology applications. A lot of people talk about risk and how to manage them, and rightly so. But it could last a much longer time before you actually have a consensus on what type of regulation should be adopted in any particular jurisdiction. And looking at the debate, there are so many different applications that have so many different properties, including some potentially very risky and some much less risky. It will take a long time to settle to a standard definition, a standard types of regulation, especially in the developed world where there's OECD is working a lot on this issue. But at the same time, there's an opportunity cost for the poor. If you wait a long time for an application that we know is quite safe or naturally derived, but also has very promising benefits, then you will have a cost to pay. So the underlying question that we probably will bring to the discussion could be that, should all nanotech applications be treated the same, and especially what can be identified as high potential, low risk applications, just like the one that will be presented today. Should they wait for a general framework on all types of nanotech, risk management be decided before moving to the field? Here are some examples of promising nanotech applications. Today we're going to have two specific examples, but I wanted to brush through a number of those applications that are a much broader range of fields. In agriculture production in particular, some application will help to have better management and stewardship of agriculture input, nano-herbicide, nano-sensors, and all of those are actually described in the briefs and in the paper. Improved animal production through the nanofeed additives that can increase the weight of animals, and improve crop production through nanofertilizer, nanoporous membrane to retail soil moisture and reduce the effects of droughts. And these are only a few in agriculture production. We'll hear about another one today. On food safety and nutrition, some of the most, perhaps the most commercialized type of application today are related to packaging, enhanced barriers to microbial contamination or spoilage. This is for regular food that is commercialized, but also could help, reduce post-harvest losses in developing countries if you were able to find, relatively cheap and cost-efficient ways of reducing, microbial contamination. Detection of pathogens, nanosensors in packaging processing. There are some discussions around traceabilities of products in developing countries to avoid pathogens. There is a report by the World Bank that mentioned the fact that nanotech could bring a lot to the table. Nano-based veterinary treatments, such as nanoclays to decrease aflatoxin effects. We have some research here in IFPRI working on aflatoxins and showing how much it's an important issue to address. Detection of pesticides, heavy metals, or other chemical contaminants also matter. I didn't bring here the nutritional, but there are also some nutritional applications that really are being developed. On the water safety, today we're going to talk about, we're going to hear about improved filtration mechanisms, some really effective to remove water pathogen or contaminants that are prevalent in so many countries, improved detoxification of harmful pollutants, and remediation. So these are a few bullets, among others, that show us that there is some potential. But there are also challenges ahead, and in the paper and both the brief as well, we discuss what could be those challenges, especially if you want those applications to be used by the poor. First one is the research and development investment will be targeted for the need of the poor. A lot of research and development is concentrated in developed countries and not necessarily looking at what application could be useful for the poor in developing countries. Today we are lucky to have two speakers talking about publicly developed innovations that could actually make a difference in developing countries. But not all the applications are being developed in the public sector, and there are IPR and other issues that are being discussed. The second one is the cost and access to nano application. If you do have a great application, a great technology that you think would have a huge effect, can it actually be affordable and available to the poor? And the third one I already mentioned is risk and regulatory issues that really matter. And during some discussion we had last year at an FAO conference, the first international conference on nanotechnology in agriculture, I brought some points here on what I thought would be important issues to address on the risk and regulatory side. The priority should be to set balanced approach to regulation, monitoring risk perception and the acceptance of nanotech, and then anticipating and managing market risk. So all those three issues and the little bullets here are topics that we at IFPRI would be interested to work more on, and more widely the CGIAR we think should play a role in making sure some of those applications can move forward in a safely manner. To finish, I just wanted to tell you what we've already mentioned. We have published a brief and a discussion paper. These are only review papers, and we really are interested in moving towards more application and specific cases of nanotechnology and what can they bring to the poor. So, thank you. I'll let Winston.